In the last period, my dear students, we have studied about the various types of redox reactions, and after revision, now let's move to the next question for us. Which of the following species does not show disproportionation reactions and why? What is the reason? ClO minus, ClO2 minus, ClO3 minus, ClO4 minus. Also write the disproportionation reactions for each species that disproportionate. Let us understand. Species in which element is present in its highest oxidation state or lowest oxidation state, they cannot disproportionate. So those species which have the highest oxidation state or lowest oxidation state, they cannot disproportionate. If you look into the ClO minus, see 2 minus 1 is 1. So here we have plus 1 oxidation state. 2 to the 4 minus 1 is 3. So here we have plus 3 oxidation state. 3 to the 6 minus 1 is 5. So here we have plus 5 oxidation state. 4 to the 8 minus 1, it's 7. So we have plus 7 oxidation state. Now this plus 7 is the highest oxidation state for chlorine, because chlorine show minus 1, 0, plus 1, plus 3, plus 5, plus 7. These are the various oxidation state chlorine can exhibit, and that is why the plus 7 is the highest oxidation state, whereas minus 1 is the lowest oxidation state. So when chlorine is in minus 1 oxidation state or it is in plus 7 oxidation state, it cannot show disproportionation reactions. So in all the other cases, chlorine in minus 1 and plus 7, it is the lowest and the highest oxidation state where it cannot undergo the disproportionation reactions. So ClO minus, ClO4 minus does not disproportionate, but all the other species disproportionate, and you can see these various reactions as on your screen, my dear students, that you can see that this ClO minus, where Cl is plus 1, is disproportionate and goes to the minus 1 oxidation state as well as plus 5 oxidation state. So ClO minus gives 2Cl minus and ClO3 minus 1. Same way, my dear students, you can see here that our chlorine ClO2 minus has got Cl plus 3 oxidation state, where it can goes to the plus 5 oxidation state where oxidation takes place, and from plus 3 it goes to the minus 1 oxidation state where the reduction takes place. When we have Cl plus 5, it goes, ClO minus 3 goes to the 3ClO4 minus, so plus 7 oxidation state. And the reduction when we have the Cl minus, which is minus 1 oxidation state. So these are the various disproportionation reactions that we can write for ClO minus, ClO2 minus, and ClO3 minus. Now let's move and understand or solve the next question. Suggest a scheme of classification of the following redox reactions. So we need to identify what kind of redox reaction the reaction given is. Here you can see that two reactant gives one product, so it's a combination reaction. Here one reactant gives more than two products, so it is a decomposition reactions, my dear students. Please have a look to this. The next reactions we can see. Here you can see that NaH reacts with H2O, it produces NaOH and H2. Hydroxide of water is displaced by the hydride ion, so it is a displacement reactions. It is actually H minus plus H2O that gives OH plus H2. Here, hydrogen from plus 1 oxidation state goes to 0 oxidation state, which is an oxidation, and hydrogen from minus 1 oxidation state goes to the 0 oxidation state. So here you can see that both these hydrogen goes to 0 oxidation state. So here it is something that happens which is exactly opposite, to the disproportionation reactions. You can see here that from minus 1 and plus 1, both these oxidation state goes to the 0 oxidation state. So here one hydrogen is oxidized, one hydrogen is reduced, and both goes to the same oxidation state, that is 0 oxidation state. The above reaction is the example of comproportionation reactions. So these kind of reactions, when a single element undergoes both oxidation and reductions and give the single oxidation state. Such reactions are exactly opposite to the disproportionation reactions, and they are either known as the comproportionation reactions or they are known as the symproportionation reactions. So please remember, this is a wonderful example of a symproportionation reaction or a comproportionation reaction, my dear students. Please remember this reaction, which is the example of symproportionation reaction or a comproportionation reactions, because here two different reactants, they undergoes and gives the single oxidative products. Now, next, my dear students, let us read the definition. Comproportionation reaction or symproportionation reaction. So, it is the type of redox reaction or redox chemical reaction in which two reactants containing same element in different oxidation state will form a product in which element reach same oxidation state. Here H minus 1 in NaH and H plus 1 in H2O reach the same oxidation state, that is 0 in H2, and that is why such reaction is known as the comproportionation reaction or symproportionation reactions. We have the last reaction to understand, that is 2NO2 plus 2OH minus, that gives NO2 minus, NO3 minus and H2. Here you can see that the plus 4 oxidation state from NO2 undergoes plus 3 oxidation state, that is reduction, and plus 5 oxidation state, that is oxidation. So here the same element from the same compound undergo both the reduction as well as oxidation, and that is why this reaction is known as the disproportionation reactions. Now we have the next question to solve, my dear students. Let us look into the questions. Why do the following reaction proceed differently? Pb3O4 reacts with 8HCl. It gives PbCl, 3PbCl2, Cl2 and 4H2. But Pb3O4, when it reacts with the HNO3, it gives us PbNO3 twice, PbO2 and 2H2. So here you can see that we get a different kind of products, that is PbO2, which is not found into the previous reactions. What is the reason that why Pb3O4, when it reacts with the hydrochloric acid, it gives different products as it is when it reacts with the nitric acid? What is the reason? Let us find out the reason and understand it well. We have already studied, my dear students, that Pb3O4 is a mixed oxide. It is the mixture of 2 mole of PbO and 1 mole of PbO2. The oxidation state of Pb in PbO2 is plus 4, and in PbO the oxidation state of Pb is plus 2. In PbO2, Pb has got highest oxidation state for Pb, which is, so it behaves as an oxidizing agent only, because from highest oxidation state, that is plus 4, it can be reduced only. Now it cannot be oxidized. So as it cannot be oxidized, it can be reduced, and that is why PbO2 behaves as an oxidizing agent only. It cannot behave as a reducing agent because it is present into its highest oxidation state. And as it is in highest oxidation state, it itself cannot be oxidized, and as it cannot be oxidized, it can be reduced only, and as it can be reduced, it behaves as an oxidizing agent, but it cannot behave as a reducing agent. And thus it oxidizes Cl minus. So this PbO2 oxidizes the Cl minus to Cl2, this Cl minus from HCl. So my dear students, our PbO2 oxidizes Cl minus from HCl to Cl2 and itself reduced to Pb plus 2 as a PbCl2 when it comes to the reaction with HCl. So when it comes to the reaction with HCl, my dear students, PbO2 reacts with HCl and PbO2 converts itself into the PbCl2 and it converts 2Cl minus to Cl2. While 2 moles of PbO, which is basic oxide, remember PbO is a basic oxide, give acid-base reactions and not a redox reactions. Please remember that PbO, when it reacts with HCl, it gives the acid-base reactions and not the redox reaction. So if we want to write the reactions for 2 PbO, let us write it here. If we have 2 PbO, it reacts with HCl. So it reacts as an acid sorry, this is base actually. So this acid plus base, that gives us the salt and water. So here we can see that PbO gives PbO gives PbCl2, where the oxidation state of Pb, which was plus 2 here, here even it is plus 2. Here we have 2 Pb, so we will put 2 here. So we need 4 HCl, 4 Cl minus, so we will put 4 HCl, and this is how, my dear students, we will get 2 H2O. So here you can see that the oxidation state of any of these elements have not been changed. So it is a simple acid-base reactions that PbO gives with the HCl when it reacts. But my dear students, when PbO2 reacts with HCl, it gives a redox reaction and gives us a PbCl2. It also produces Cl2. So this is what it happens. And it also produces 2H2O, because PbO2, these two O are there. So we need actually 4 HCl here. So here you can see that Pb from plus 4, it goes to the plus 2. So there is a reduction, and Cl, which was minus 1, it goes to the 0. So here it is the oxidation. So reaction of PbO2 with HCl is actually the redox reaction, whereas reaction of PbO with HCl is actually the acid-base reactions. When we add both these reactions, what happens? We get PbO plus 2 PbO2, that is Pb3O4. 4 HCl plus 4 HCl, we get 8 HCl. We get 2 PbCl2 and PbCl2. So we will get 3 PbCl2. We will get 4 H2O and we will get Cl2. So if we look into the question, we will find the same kind of reactions. Pb3O4 plus 8 HCl. So when we add both these reactions, oh, I have already shown you these reactions. You can see that I have shown you these reactions, that when PbO2 reacts with 4HCl, it gives PbCl2, Cl2 and 2H2O. When PbO reacts, it is simple acid-base reactions. It gives 2 PbCl2 and 2H2O. So when we add both these reactions, we will have Pb3O4, 8HCl, that gives 3 PbCl2, Cl2 and 4H2O. So this is what it happens. But when it comes to the reaction with HNO3, my dear students, let us see what happens. But when Pb3O4, that is PbO plus 2 PbO plus PbO2, reacts with HNO3, oxidation state of nitrogen is plus 5, which is highest oxidation state for nitrogen. If you look into the HNO3, my dear students, nitrogen has got, see, this is minus 6, this is hydrogen is plus 1, so it goes plus 5. Now plus 5 oxidation state is even the highest oxidation state for nitrogen. So even nitrogen present into the HNO3 behaves as an oxidizing agent, and it itself would like to be reduced. So both PbO2 and nitrogen of HNO3 have highest oxidation state, and both want to reduce each other. So both these oxidizing agent, the oxidation state of nitrogen is plus 5, which is the highest oxidation state, and HNO3 also behaves as an oxidizing agent. So as both HNO3 and PbO2 are oxidizing agent, they do not react with each other. And as they do not react with each other, only PbO2 from Pb3O4 give acid-base reaction. So you can see that the acid-base reaction given by 2 PbO plus 4 HNO3, it gives 2 PbNO3 twice plus 2 H2O. This PbO2 which was present into the Pb3O4 remains as usual, and it does not give any reactions. So when we add both these reactions, we get Pb3O4 plus 4HNO3, we get Pb3O4 plus 4HNO3, you can get 2 PbNO3 twice plus PbO2 plus 2H2O. And that is why both the reactions of Pb3O4 with with both the reagents, either it may it be the HCl or it may be the HNO3. Both the reactions are different, and the extra product PbO2 is obtained when when our Pb3O4 reacts with the HNO3, because both HNO3 and PbO2 are oxidizing agent, and that is why PbO2 does not give any reaction with nitric acid HNO3. So this was a interesting case, my dear students. Now let's move and understand the balancing of redox reactions. There are two various methods used for the balancing of the chemical equation for the redox processes. So first, let us study the method which is known as the oxidation number method. Let us understand this method with an example question. So let's follow and understand the oxidation number method. The the question is, write the net ionic equation for the reaction of potassium dichromate uh, 5 K2Cr2O7 with sodium sulfide Na2SO3 in an acidic medium to give chromium 3 ion and sulfate ion. So this is the question, my dear students. Let's answer the question and understand the oxidation number method stepwise. So for the given question, my dear students, first we need to write the equation. So we have potassium dichromate and sodium sulfate. They react with each other to give chromium plus 3 ion and SO4 minus 2. Now here this sodium and potassium ions are the ions which are not seen into the right hand side. So we can consider them as the spectator ions. These ions are known as the spectator ions. So these spectator ions needs to be removed from this reaction, and we should write the ionic equation. So as product side potassium and sodium are not present, we can write net ionic equation as Cr2O7 minus 2 plus SO3 minus 2, that gives Cr plus 3 and SO4 minus 2. Now let us understand how to balance such equation stepwise. So in this method, first step, write the correct formula for each reactant and product. So we have written the correct formula for each reactants and products, and then we move to the next step. Step number 2. In this step number 2, we assign the oxidation number and find out the atoms undergoing the change in oxidation number. Then we balance the number of atoms other than hydrogen and oxygen by multiplying with the suitable stoichiometric coefficients. So in the second step, we need to first write the skeletal equation, then we need to assign the oxidation number. So you can see that I have written the skeletal equation, then I have assigned the oxidation number to all. So 7 to the 14 minus 2, it is 12 divided by 2, so it is 6. So here the oxidation state of chromium is plus 6, and for oxygen it is minus 2. For sulfur, if you think, see 3 to the 6 minus 2, which is plus 4. So for sulfur we write plus 4, and for oxygen we write minus 2. Here chromium has got plus 3 ion, and sulfur again 4 to the 8 minus 2, that is 6. So the oxidation state of sulfur is plus 6. So now by assigning the various oxidation state, I can find that chromium from plus 6, it has been converted to plus 3, so it's a reduction process. And for sulfur from plus 4, it goes to the plus 6 oxidation state, and that is why this is the oxidation process. Now my dear students, chromium, both the side are not equal. You can see that here we have 2 chromium and here we have only 1 chromium. So let us write the equation in a new manner where both the side, the atoms other than oxygen and hydrogen should be balanced. So other than oxygen and hydrogen, my dear students, we have chromium and we have sulfur. At left side we have 2 chromium and right side we have only 1 chromium. Left side we have 1 sulfur and right side we have 1 sulfur. So only chromium needs to be balanced. To balance this chromium, we multiply this chromium plus 3 with 2, and finally we write the equation Cr2O7 minus 2 plus SO3 minus 2, that gives 2 Cr plus 3 plus SO4 minus 2. Now both chromium and sulfur are balanced into the given equation, and that is why we can move forward and solve the other part of the equation. Let's move forward and understand. Now, what happens in the step 3, calculate the increase or decrease in the oxidation number based on the electron transfer. So now we want to find out the increase or decrease into the oxidation number based on the electron transfer. Here you can see that 2 chromium from +6, they go to the +3. So what happens? This +6 to +3, actually for each chromium, there is the transfer of 3 electrons. So my dear students, you can see that chromium +6 gets 6 electron to give 2 chromium +3. So each chromium, what happens? Chromium +6 get 3 electron and gives us Cr +3. But we have 2 chromium, so we need 6 electron and we get 2 Cr +3. So total transfer of electron is 6 electron. Now my dear students, when we look at the sulfur, sulfur from +4 goes to +6. That means, my dear students, sulfur when from +4 it goes to the +6. What happens? Sulfur +4, it turns out to be sulfur +6 and it has to release 2 electrons. But my dear students, we have only one sulfur, so there is total exchange of 2 electron only. Now we need to take the LCM of both these numbers and then we need to multiply the, so here we can see whatever I have written, I have shown you once again. Let us look at this. This is what you need to think in your mind, that 2 Cr +6 gets 6 electron to give 2 Cr +3. This 6 electron I have written here. If you have S +4, that gives S +6 and 2 electron. So this S +4 get 2 electron and releases 2 electrons and turns out to be S +6. Now the number of electrons written in the above manner, if they are not equal, here they are not equal. One is 6 electron, another is 2 electron. So if they are not equal, we need to make them equal. This exchange of electrons should be equal in both these cases. So to make them equal, so we need to take LCM of both these numbers of electrons and need to multiply the reactants and products in which the oxidation or reduction atom is present with the suitable number. So now you can see here that once we have 6 electron, another we have 2 electrons. So those which are having the 2 electron, see LCM of 6 and 2 is 6. So those species which are involved in 6 electron exchange, they need to multiply with 1. But those species which are involved in 2 electron exchange, they need to multiply with 3. So here, my dear students, I have written it clearly that it is something that you can see here, that this 6 electron, this 2 electron, these species which are involved, they need to multiply with 3 so that the total exchange of electron would be same. So by multiplying the species containing sulfur by 3, we can write the equation once again. So we have written this equation once again, Cr2O7 minus 2 plus 3SO3 minus 2, that gives 2Cr plus 3 plus 3SO4 minus 2. Now as we have 3S, the total exchange of electron is 6 electron. Here also 2Cr plus 3 will have 6 electrons. So now the electrons are balanced. Now we want to balance the hydrogen and oxygens. Now we want to balance the atoms, oxygen and hydrogen. For acidic medium, my dear students, we want to find out, or we will have to follow a different method. So for acidic medium, find out the number of oxygen both the side and determine the oxygen deficient side. First of all, you need to calculate the number of oxygen, and then you need to find out that whether the reactant side or product side is deficient in the number of oxygen. If oxygen deficient side has X number of oxygen less, once again, if oxygen deficient side has X number of oxygen less, add X mole of H2O to the oxygen deficient side. Those sides which are less oxygen present, and if X oxygen are less, we need to add X H2O to that side and look for the number of hydrogen atom both the sides. So when we look at the reaction, my dear students, we will come to know that here Cr2O 7 minus 2, so we have 7 oxygen, 3 3s are 9, so 7 plus 9 total we have 16 electrons. Here 3 4s are 12, we have 12 electrons. So this side is oxygen deficient and this side has 4 oxygen less. To balance the oxygen, we will have to add 4H2O this side. So we add 4H2O. Let us add 4H2O product side and we write the equation once again. So let us read the equation. Cr2O7 minus 2 plus 3SO3 minus 2, that gives 2Cr plus 3SO4 minus 2 plus 4H2O. This 4H2O extra we have added to it. Now let us calculate the number of oxygen. So here the number of oxygen at left side it is 16 and now at right side 3 4s are 12 plus 4 16. So now the oxygens are balanced both the side and balanced number is 16. But when we look at the hydrogen, left side we have 0 hydrogen, but on right side now we have 4 to 8 hydrogen. To balance this equation, let us add H plus to the deficient sides. So hydrogen on the product side 8 but reactant side 0. To balance the hydrogen, if Y number of hydrogen atoms are less one side, add Y number of H plus to the uh, H atom deficient side. So here we have the left side H atom deficient, and that is why the same number of hydrogen which are deficient on the left side, the same number of H atom we need to add. And that is why here reactant side H atoms are less. So let us add 8H plus to the reactant sides. So now we will add 8H plus to the reactant side and we will write the reaction once again. So we will have Cr2O7 minus 2 plus 3SO3 minus 2 plus 8H plus, that gives 2Cr3 plus 3SO4 minus 2 and 8H2O. Now let us verify the various atoms whether they are equal both the side or not. Chromium this side 2, that side also 2. Oxygen this side 3 3s are 9 plus 7 16. Here 3 4s are 12, 4 3s are 12 plus 4 16. Sulfur this side 3, that side also, or the right side even we have 3 sulfur. Hydrogen this side 8 and on the right side 4 2s are 8. So all the atoms chromium, sulfur, hydrogen and oxygens are balanced now. Now in the final stage, when both the side, if we have all the atoms equal, go to the next step. What is the next step? Calculate the charge both the side, and if it should be equal, if so, we have balanced the given chemical equation. So now we need to find out the total charge present in the left hand side as well as right hand side. You can see in the left hand side we have minus 2 charge. So we have written here SO3 has got minus 2 charge, that needs to be multiplied with this 3. So 3 into minus 2, that gives minus 6. And here at 8H plus, so it is plus 8 charge. So minus 2 minus 6 plus 8, that is minus 8 plus 8, that is equal to 0. Now let's look at the right hand side. 2Cr plus 3, that is plus 3 multiplied by 2, that is plus 6. 3SO4 minus 2, that is minus 2 multiplied by 3, that is minus 6. And here even the right side, the total charge is 0. Thus, my dear students, both the side we have equal charges, and we can say that here we have both the side charges are equal. So our equation is balanced. So this is how even we confirm whether we have really balanced the equation properly or not by calculating the charge both the side, and this is how we can understand the equation is being balanced. Now we have studied the fourth step, and in the fourth step we have studied how to balance the equation into the acidic medium. But suppose instead of the acidic medium, if we have basic medium, how can we balance the oxygen and hydrogen into the basic medium? So for basic medium, the oxygen deficient side should be added with a 2x OH minus. So suppose the oxygen deficient side has 5 oxygen less, then we need to add 10 OH minus to that side. If the oxygen deficient side has 4 oxygen less, then we need to add 8 OH minus to that side. And opposite side should be added XH2O. So if you add 8 H2O one side, then opposite side add 4 H2O. If you add 10 H2O one side, then opposite side add 5 H2O. So this is the process for the balancing of the hydrogen and oxygen in case of the basic medium. This must be done simultaneously, and then we should check the number of hydrogen atoms. According to the requirement, now H2O and OH minus either added or removed to balance the oxygen and hydrogens. So according to the requirement, when we add the OH and H2O both the side, and if even the hydrogens are not balanced, according to our requirement, we can add H2O and OH minus both the sides. We can even remove the H2O and OH minus from any of the side, and we can balance this equation into the basic medium. To balance hydrogen in the basic medium, to balance hydrogen in the basic medium, determine the hydrogen deficient side. If X hydrogen are deficient, add X H2O to the deficient side. Suppose there is one side X hydrogens are deficient. So that side where the hydrogens are deficient, add X H2O to deficient side. Suppose a deficient side has got 3 hydrogen deficient. So you add 3 H2O to the deficient side and add X OH minus to the opposite side. So you add 3 H2O, whatever the side you add 3 H2O, exactly opposite side you need to add 3 OH minus. This is how your hydrogen will also be balanced. Please remember these methods, and this is how you can balance the hydrogen even into the basic medium. To understand this, let us study one of the examples so that we can understand it better. Balance the following equation. Balance the following equation in the basic medium by oxidation number method. We have P for solid plus OH minus, that gives PH3 plus HPO2 minus. Now here we will follow the method which is utilized into the basic medium. To solve this, we will have to do some more task also. It is very interesting case, and it is the most difficult equation to be solved by the oxidation number method in your textbook exercise. So that is why I have chosen this, and let us solve this. Here, let us say that OH minus ion is just to show the basic medium. So let us remove it from the for the convenience and rewrite the equation. So you can see that here they have shown you the OH minus. This OH minus is actually utilized to balance hydrogen and oxygen. So let us remove it because it just shows the basic medium. There is no other use of this OH minus. So finally we write the equation as P4, that gives PH3 and HPO2 minus. Now we need to assign the oxidation number to all. So for P4 we have 0. For PH3, P has got -3, and for HPO2, P has got +2. So you can see that this same P4 undergoes reduction, undergoes oxidation. So this is the case of the disproportionation reaction. But that is the redox reaction, and we can easily balance it even whether it is the disproportionation reaction or not. This disproportionation reaction, it is difficult to balance P both the side, because you can see that here, suppose you multiply this, or it is as the same P4 molecule undergoes both oxidation and reductions. For our convenience, my dear students, let us take 2P4 so that we can understand the oxidation and reduction in a better manner. So let us say for convenience, we have 2P4 molecules and to balance, let us multiply both the products with 4. This will help us to calculate the transfer of electrons well. So here what we'll do, instead of just writing one P4, we will write P4 plus P4. So now we will have 2 P4 molecules from which there will be an oxidation and reduction that can be done. We already know that to balance the equation, first we need to balance the atoms other than oxygen and hydrogen, and that is why to balance the P, we multiply both the products with 4 because each product contains only one P. So now we can write the equation as P4 plus P4, that gives 4PS3 plus 4HPO2. Now, my dear students, we need to calculate the electron transfer. You can see here that from P from 0 oxidation state goes to P minus 3. That means it has got 3 electrons. Same way here, if you look at, you can see that P that goes to P plus 2. That means it will release 2 electrons. So if we write both the things left hand side, you can see this is P plus 3 electron. Here you can see P minus 2 electron, that gives you P plus 2. So this plus 3 electron and minus 2 electron I have written here. You can see here plus 3 and minus 2. But we have 4P. So we need to multiply all this with 4. So here we will have 8. Here we will have 12. Uh, so we need to multiply it with 4. Here also we need to multiply it with 4 because we have 4p. So we multiplied with this, and that is why we got 12 electron this side and 8 electron this side. Now, my dear students, by multiplying them, we come to know about the total number of electrons that has been exchanged. What is the next step? In the next step, we need to take the LCM of 12 and 8, and then we need to multiply these numbers with the suitable coefficient. So LCM of 12 and 8 is 24. So to get 24 from 12, we need to multiply it with 2. To get 24 from 8 electron, we need to multiply the various species with the 3. So these species where the oxidation is involved, we multiply them with 3. Those species where the reduction is involved, we multiply them with the 2. So let us write this reactions by proper multiplication. You can see that this P4 I have multiplied with 2, so we get 2P4, and this 4PS3 I have multiplied with 2, so we get 8PS3. Same way this P4 has been multiplied with 3, so we get 3P4, and this HPO2 minus is multiplied with 4, so we get 4 multiplied by 3, so 12 HPO2 minus. Now, my dear students, if you look at the number of oxygen both the side, you can see that at the left side we do not have any oxygen, but at the right side we have 12 to the 24 oxygen present. This is the basic medium, and we can now easily identify that the reactant side is oxygen deficient. Reactant side is deficient with 24 oxygen. So let us add 48 OH minus to the reactant side and 24 H2O to the product side. We are well aware that the oxygen deficient side will be added 2x OH minus, and the opposite side will be added x H2O. So 2x, that is 48 OH minus, is added to the reactant side, and 24 H2O is added to the product side. So we get the new equation, that is what is the new equation? Let us look at, my dear students. For this 2P4 and 3P4, I have written 4P4. 3 plus 2 is 5, so I have written 5P4. Now I have added 48 OH minus to the left hand side, and I have added 24 H2O to the right hand side. Then this 8 PS3 and 12 HPO2 minus I have written as usual. I did not make any other changes. Now when I calculate the number of oxygen, left side it is 48, on right side it is 48. But when I calculate the number of hydrogen, left side it is 48, but right side it is 24 plus 12 plus 48. That is 24 plus 12, that is 36 hydrogen is extra on the right hand side. Now we have seen that the hydrogen deficient side is again the left hand side. So reactant side has 36 hydrogen deficient. That is why we, to balance hydrogen, let us add 36 H2O to the left hand side or reactant side and 36 OH minus to the product side. So now we have the new equation, my dear students, that we have added 36 H2O to the left hand side. So we will have 5p4 plus 48H2O plus 36H2O, and on the right hand side we have 8pH3 as usual, 12HPO2 minus as usual, 24H2O as usual, and extra 36OH minus is added. Now we want to calculate the number of oxygen and hydrogen. So when we calculate the number of hydrogen, it is 48 plus 36 multiplied by 2, that is 72, which is 120. On right hand side, if I calculate the hydrogen, 8 3s are 24, 12 2s are 12 1s are 12, 24 2s are 48, and 36 OH minus, so 36H. So 36, 24 plus 12, 36 plus 48 plus 36, 36 plus 36 is 72 plus 48, which gives us ultimately 120 hydrogens. So now both the sides we have hydrogens are balanced, we have oxygens are balanced. Now we can remove the OH minus and H2O which are extra. So on the left hand side we have 48 OH minus, and on the right hand side we have 36 OH minus. So 48 minus 36, 48 OH minus minus 36 OH minus, we will have only 12 OH balance on the left hand side. On the right, in case of the H2O, if you look at, here we have 36 H2O and here we have 24 H2O. So 36 H2O minus 24 H2O, that gives 12 H2O. So even on the left hand side we will have 12 H2O remains. So now after removing the H2O and OH minus, we can write the final equation as 5p4 plus 12OH minus plus 12H2O, that gives 8pH3 plus 12HPO2 minus. Now my dear students, if we calculate the number of various atoms, we can come to know that we have oxygen that is equal to 24, we have hydrogen that is equal to 36, we have phosphorus that is equal to 20, and charge even 12 minus 1, that is minus 12. Sorry. Even if you look into the number of oxygen, 12 2s are 24, the number of hydrogen, 8 3s are 24 plus 12 1s are 12, total 36. Phosphorus, if you look into this, 8 phosphorus plus 12 phosphorus, so total 20 phosphorus, and charge this minus 1 multiplied by 12, so it is minus 12. So now we confirm that we have completely balanced the equation, because even the charges are equal both the side, and then we can write the complete balanced equation, my dear students. So let us so this is the way we can understand the complete balanced equation. We will study about the half reaction method or ion electron method into the next class. Now if you have any doubts, my dear students, let us discuss the various doubts of yours, and or else we can move to the next part.